All right, next up we have Amanda Liczner with the presentation topic of Unveiling Critical Habitat, Behavioral Insights into Overwintering and Nesting Environments, Bumblebees using Radio Telemetry.
Hi, everyone. It's great to be back at BCon in York University. I thought I was never going to leave. I did my undergrad, master's, and PhD, and now I'm back again, so you can't get rid of me. Sorry, guys. I'll try and get us back on time, but I love talking about this project, so we'll see about that.
We miss you already.
I miss you too, guys. Now I lost what I was going to say. So my presentation is a little bit different. I've been doing some radio telemetry with bumblebees. Can't believe it, for almost 4 years now. So I'm going to present some, I think, cool findings that we've had doing this project over the last almost 4 years. So the first thing people usually say when they hear my project is, what do you mean you're doing radio telemetry with bees? How is that possible? And so, yes, we are doing radio telemetry with bees. We have really tiny radio tags, as you can see on the back of that Bombus impatiens queen there. We glue them to their backs, and then we have an array of radio towers. There's approximately 44 of them set up throughout the field. On the far left, there's a picture of what a radio tower looks like. So we set all of those up every year and put them down every year. It's a lot of fun. And the size of the radio tag is shown at the bottom by in reference to a Sharpie. So they weigh about 0.13 grams. The tags come at about 10 centimeters length, but we cut the antenna down to half that, because we found that the long antenna would get tangled up in the vegetation, and that was not very nice to the bees. So it's actually smaller than a Sharpie. So what kind of data can you get from doing radio telemetry stuff? Well, you can get all kinds of cool stuff. So just from the GPS points of where we pick up the bees, you can get the location information. You can use that to do kernel density estimates. Kernel density is just how many points are in an area, so you can see where they're spending more of their time. You can do something called minimum convex polygons, which is a crude estimate of home range. If I wander outside of the video, you'll tell me, right? Okay, cool. So we can get an estimate of home range of the bees. You can make flight paths and make cool GIFs like the image shown up there. With flight paths, you get stuff like step length and turning angle, which can tell you stuff about their habitat selection as well as their behavior, the different behaviors that they'll show. So if they're doing transit, if they're potentially foraging, if they're avoiding different areas, and then something called step selection functions, which can also help you determine areas that they are preferring to travel through versus avoid. So here are some of the fun facts that we found. Bumblebees are flying at night. About 30% of the time that we get data back, it's at nighttime. I don't know what they're doing because I'm not there at night, I'm sleeping. It's at all times of night, 5 in the morning, like when the sun's down, 5 in the morning, 8 p.m., midnight, they are moving. And I don't know why. It's across all the studies we've done stuff with pesticides, different habitats, nutrition, doesn't matter. They're always flying. Spring queens, fall guides, about 30% of the time they're flying. I don't know why. That has important implications though for some pesticide regulations require that you spray and at dawn or dusk, not at night, at least not when the sun's up, so that it limits exposure. They're still flying at night though, so they could be getting exposed. So we only tag queens and mainly of Bombus impatiens just because they're the biggest, the easiest to find. They have commercial colonies. So I'm presenting the results for gines, which are their overwintering behavior, either right before they go into overwintering or when they're overwintering. And then later I'll present the spring queens and what they're doing. So gines often return to the same exact flower. So sometimes you'll see them foraging and get really excited because you don't see them very often. You catch her, you put a tag on, put her back on the flower, come back the next day, she's still there sleeping. And she'll do that for a few days. So if you're trying to do stuff with gines, it's quite easy. Just remember where you caught them and you can find them again. And gines are very lazy. So this is a graph of their behavior. So on the left is ARS, which stands for Area Restricted Search. It's a movement behavior term for they're doing something in this area, very concentrated. So for bees, it could be like foraging, nest searching, overwintering searching. Just we didn't observe what they were doing, so we can't be 100% sure what they're doing, or rest. And on the bottom is the different land cover classes, and we have day and night. So gines spend the vast majority of their time in all the land cover classes just resting, which makes sense. Their only job is to get fat and mate and then overwinter. So they shouldn't be flying around expending their energy. But fun fact, but not so fun fact, pesticides seem to make them move a lot more, which isn't so great. An activity period for guides has varied between the years. The first year that we did any radio telemetry, they were flying on average for about a month, which I thought was very strange. Because again, all they need to do is get fat, mate, and overwinter. And the literature suggests they should only be active for about 2 weeks. So mine were active for about a month. So we were curious about what this was for. So we thought maybe it was nutrition, that the queens couldn't find enough food to get fat so that they could overwinter. So we did a nutrition experiment where we fed colonies really, really good food, gave them tons and tons of pollen, high sugar content, and we gave the colony restricted pollen, less sugar content, and then we released the guides and tagged them to see if those poor fed colonies were going to be active for longer than the colonies that were given all kinds of food. We found there was no difference. And we actually found that they were active on average for 2 weeks. So big question mark there. One thought is guides get released for at least bombus impatiens over a period of time. There's like the early emerging guides, and then there's the stragglers that come out later. A lot of the queens that I had tagged when they were active for about a month were from a nest that I just happened to find and tagged a bunch of guides from there. They could have been some of the stragglers, the later emerging bees. So maybe it's more with the time that they leave the nest rather than a nutrition thing. But that's something we haven't tested yet. Maybe this was not news to you, but it was news to me. When queens are looking for overwintering sites, they do the similar zigzag pattern as nest searchers. So and everyone knows about nest searching. Well, bumblebee people know about nest searching. Flight, the queens will fly low to the ground. They do this zigzag thing where they check out different patterns, and it's a very unique behavior of spring queens. But in the fall, the guides are doing the exact same thing while looking for overwintering sites. We saw this while we did that nutrition experiment by the colony boxes. They were zigzagging around. Queens, or guides, sorry, I should say, also seem to wander overwinter near the nest, or at least for bombus impatiens where we've done most of this work. But it also might depend on when they emerge. So like I said, with the colony boxes, when we put out, a lot of the queen or guides that we were observing were doing that overwintering search right near the colony boxes. And some of them were overwintering because when I had the little tag and I had my antenna, I could point at the ground right beside the colony box. So they like being near the nest. And that year that I tagged the queens near the nest is the star on the map. The reason I saw it is I saw a bunch of queens digging in the ground right beside the nest entrance. So they were overwintering right at the nest entrance. But we also have, this doesn't show up on here. Okay, sorry. That little aggregate of dots, those are all individual guides that are overwintering down in that corner. So it's maybe they just like to overwinter near each other. They want to have some buddies when they wake up or while they're sleeping. Or maybe it's the early bird gets the worm. The earlier ones that are emerging, maybe they're the ones that get to overwinter near the nest, which is the preferred spot. And then the later ones just go and find some buddies to overwinter with. Maybe there was another nest there. We're not too sure. But they seem to like to overwinter in aggregates. And this was observed for both our wild caught guides, bombus impatiens, and the commercial. So not sure if it's the same for other species. And then just what does the overwintering habitat look like? So on the left, the bar chart is for average step length, and the right bar is for kernel density. So for step lengths, if they like a spot, they're probably going to take small step lengths. Step length is just distance from point A to point B. If you want to stay there for your flowers, you're probably going to be hanging out, taking small steps. But if you want to get past an area because you don't like it, you'll be taking large step lengths. So for guides, the smallest step lengths are in high floral areas, which makes sense. They need to eat. And the larger and more variable step lengths are in the other land cover classes. For kernel density, it's the opposite. Higher density areas means they like that because there's going to be lots of points there. We're getting lots of detections there. So again, it's in high floral areas as well as forests, and not so much in agricultural low floral areas. So we're going to switch to spring. I think I might actually get us on time if I keep talking this fast. So some nesting observations of bombus impatiens. So this would be their movement before and after starting a nest. So this year we did a cool experiment because I knew where some queens were hibernating. We sat there and we waited for them to wake up, and then we tagged them right when they woke up. So we saw that queens are very groggy when they wake up. They will stay in the same spot all day. for 3 or 4 days at a time. Or at most, they move a few meters away. And I know that because I got my research assistant to sit there and watch the bee while I did some other stuff, and he wasn't moving because neither was the bee. And there she was, just hiding they like leafy debris, moss and stuff to take a nice nap in. So if you're trying to do something with queens right when they wake up from hibernation, you might not need to know exactly where their hibernation spot unless that's really critical for your experiment. So you see a spring queen being super sleepy, you're probably within meters of their overwintering location. Unsurprisingly, they are more active than guyns. They fly all over the place. They're less predictable. If I caught them on an apple blossom and released them, I didn't find her on the apple blossom again. This is maybe because floral researchers are just less predictable in spring. They're shorter time periods. Later in the spring, they got a little more predictable, and that could be where they're going from nest to their favorite floral patch and back. You can kind of see that in this flight path. The orange is a more recent flight path, and she's going back and forth, back and forth, back and forth over top of that line multiple times. So in the early spring, it's harder to find them again, but later in the spring, it got a little easier. We were trying to collect queens with pollen so that we knew that they had a nest, and without pollen, so they might not have a nest. That pollen window for impatiens is tiny. It was a few days where you'd see them on a big shrub collecting pollen, and then all of a sudden you didn't see any collecting pollen anymore. So if you're going to try and do anything with pollen collecting queens, your time window to do that is super, super duper small. And that might have to do with pollen stores versus pollen makers behavior in bombus impatiens, bumblebees, with bombus impatiens being a pollen store. They might collect all their pollen, put it in the nest, and then they don't bother collecting pollen again until the workers emerge. I'm not sure. But yeah, if you're going to do pollen on queens, you gotta hustle. And then just some information on nesting habitat. So here's an example of a minimum convex polygon between queens that we caught that were foraging, nest searching, and that had a nest, so she had pollen. As you might guess, the foragers and the nest searchers had the biggest polygon on the left because they haven't found a nest yet. They're searching for areas. They're just feeding themselves. And the foundresses that have a nest have a smaller area, so she doesn't have to fly as far from the nest. And then for behavior, this is the amount of time they spent performing that area restricted search. So it could be foraging or nest searching. They were doing all of the behaviors a lot in low floral areas, and foragers were only seen in early floral, and then late floral was nest searching. So some other experiments we've done, I mentioned that we did some stuff with pesticides. We've done where they've consumed orally or been exposed in soil while hibernating and then radio tag them. Done landscape differences. We're in a natural area versus an agricultural site. Done a nutrition experiment that I showed. This year we tried to do species differences with guyns. We didn't find too many because it was a rough year for bumblebees. And then we've done some wild bumblebee observational behavior stuff. With that, I'd like to thank you for your attention and take any questions.